It's a sad fact that at the heart of many upsets, one of the weak links in the system is the pilot. Now, I don't want to be disparaging here because humans offer exceptional abilities in lateral thinking and problem solving, and I, for one, am a huge advocate of having a pilot in the loop. But we must recognise that human decision making, our ability to manage fatigue, and long-term monitoring and proper communication are well-known weak points in the human system. Additionally, humans are easily misled by sensory inputs, and particularly this is at its worst when there's no horizon or unclear external references. So to counter this threat, aircraft are fitted with flight instruments and head-up displays, oral tones and announcements, auto-flight systems, stall warning systems, and fly-by-wire flight envelope protections. But despite all this, humans are still a major risk factor in causing upsets. So the first step to countering this is a sound appreciation of what is going on at the heart of the aircraft. So let's look at the typical pilot-induced causes. In this section, we'll have a look at instrument cross-checks, adjusting attitude and power, inattention, distraction, vertigo and spatial disorientation, pilot incapacitation, improper use of automation, and piloting techniques and PIOs. So first of all, instrument cross-check. This is misinterpretation or fixation which can impede correct instrument cross-checking, leading to an aircraft upset. The increased risk factors that are associated with the instrument cross-check breakdowns are fatigue, inexperience, slow speed of scan, which can often be as a result of high workload, and the natural variation in pilot's ability. So the key points here are that in a high workload environment, we need effective pilot monitoring, and the pilot not flying has a duty to ensure that flight parameters are being monitored closely and should carry out their own instrument cross-check, just as if they were flying the aeroplane. In a low workload environment, we know that humans do not react well to low arousal over a long period of time, and so it may be beneficial to alternate who is the pilot monitoring at frequent intervals. Adjusting attitude and power then. Pilots need to anticipate inputs in pitch, roll, and power to effectively control an aircraft. Therefore, they must have a fundamental understanding of what they are asking the aeroplane to do and the effect that each of their control inputs will have on the aircraft. So, increased risk factors to adjusting attitude and power causing an aircraft upset, a lack of familiarity with the aircraft in question, misconceptions about principles of flight, or a momentary distraction. So the key point here is that if pilot inputs are reactionary, unplanned and excessive, the aircraft reaction may be a surprise, which can lead to over-controlling. And there have been instances of two pilots applying opposing inputs simultaneously, which demonstrates that at least one of them has a fundamental misunderstanding as to what they are trying to achieve. Moving on to inattention. This is typically where we have long cruise sectors and a very low arousal environment. And this holds an inherent risk of insidious onset of upsets. When the crew aren't watching the instruments, a small low rate disturbance of the aircraft or a deviation from course may not be detected instantly. As this escalates, it can lead to upsets. It's well known that low arousal environments are not conducive to effective monitoring over long periods. So again, consider the value in exchanging pilot monitoring duties regularly. Moving on to distraction. This is where we have an incorrect prioritization of workload due to external events or demands. The increased risk factors associated are engine anomalies, getting stuck into trying to diagnose a slight variation in an instrument indication whilst neglecting the primary job of flying the aeroplane safely. Aircraft caution lights similarly can be very alluring to the crew to monitor those and deal with that crocodile seemingly closest to the canoe rather than flying the aeroplane itself. Air traffic control demands, you can guarantee that they will come at the worst possible time. High workload environments, for instance, a complex approach into a busy airport, may lead to an incorrect prioritization. So a part of the effective monitoring duty of the pilot not flying has to be in thinking about the workload. Consider techniques for verbally drawing attention to the primary duty of flying the aeroplane for the pilot flying. This is covered at great length by crew resource management courses, so I won't labour this point, but think about questions that you could ask, such as, which speed are you going to capture? Overall though, remember that your priorities, as you were taught in your very early days of flying, are always to aviate, navigate, communicate. Moving on to vertigo and spatial disorientation. This is the inability to orientate oneself with respect to the Earth's surface. Somatogravic illusions, the feeling that gravity is somewhere other than where it actually is, can generate feelings such as leaning when upright or climbing when accelerating, and can mask high rotation rates. So increased risk factors for this are when flying at night with little in the way of external references, in certain weather conditions, distraction from instrument cross-checks which have been giving you the opportunity to reorientate yourself, and also fatigue and intoxication can be key factors. Both pilots need to be aware of this risk and be prepared to hand over and take over control if the other pilot becomes disorientated, and be aware that this can happen really at any time. Good training, flight planning and knowledge of procedures does reduce the risk because it will pre-prepare your mind as to what is about to happen to you. But overall, good instrument cross-checks greatly reduce the risk, and when disorientated, you have no option but to trust the instruments. Pilot incapacitation. This is the situation where one pilot has lost consciousness or become incapacitated and perhaps has impeded the control movement or is leaning on the controls. It also relates to the potential of a hijack scenario. Now, the most important survival factor here is that forewarned is forearmed. Consider practicing what force it would take to push back another crew member who is slumped on the controls. Can you do it with one arm whilst still maintaining good control of the aeroplane? If not, then how are you going to handle that scenario? And bear in mind that if a pilot were to slump on the controls and inadvertently push the control column fully forward, could you still manage to maneuver the crew member or carry out your plan in that scenario? Moving back towards automation and the improper use of automation is a growing concern of the industry. Upsets in this scenario are often caused by automation behaving exactly as designed, but not as the crew intended. Regulators, manufacturers and operators continue to try to find the optimum blend of hardware, software and pilot training, but when doubt pervades, the safest route is to disconnect all automation and verify you are in a manual mode to ensure a clear understanding of the situation. Do not rely on automation to fly you out of trouble. Finally, piloting techniques and the risk of pilot-induced oscillation, PIO. This is where a pilot's own inputs lead to unwanted aircraft motion. As we've discussed earlier, aircraft have inertia and there is a delay between the input and the effect of the control. Therefore, there is a risk that PIO can occur because the pilot makes an input and then feels that nothing is happening and reverses the input before the control has had an opportunity to respond. If the pilot's inputs become out of phase with the movement of the aircraft, things can magnify quite greatly. Now, this often occurs under stress, and a significant risk factor is during an upset recovery, when the control inputs that you'll be making could be much larger to those which you're used to. If you find yourself in a PIO situation, then it can be overcome by releasing and neutralizing the controls for long enough to break the cycle. In a high-stress situation, it may not be obvious to the pilot flying the aeroplane that they are in a PIO situation. So therefore, it may be the pilot not flying who realizes first and will need to verbalize that to the pilot flying. In this section, we've had a look at all of these different causes of pilot-induced upsets. The fundamental messages that we can take away from this are correct prioritization of your duties as a pilot, with flying the aeroplane safely being the #1 priority at all times. Secondly, we need to ensure that we have effective monitoring practices and good crew resource management. And thirdly, that we are putting in place suitable controls over the limitations of us as humans in the cockpit. And that does not mean an over-reliance on the automation to take control.